This is October 2025, and second variant we have, okay, you can see, and paper is first paper and without calculator version. So let's start. Question number 1, students, we have, he's saying that sketch this graph stating the x-axis intercepts. It means basically we are looking for axis means not one axis, both. It means one time I'll plug in x0, one time plug in y0. If I plug in y0, students, what happens? The z0 here. This working you are bound to show. So one time this, one time this, and one time this, one by one, all zeros. So when I plug in 1 minus x equal to 0, x minus 5 equal to 0, and 2x minus 5 equal to 0. So I got first answer 1, second answer 5, third answer is 5 upon 2. So it means 5 upon 2 is 2. So now this is a 5. 5 is a big number. So I'm writing here 1. Let me make it 1, 2, 3, 4, 5. This is enough. What is this one? 2.5. 2.5 is where in the middle sum 2.5. Where's 1 here? Actually, this all are, let me check. Yeah, all are positive values. All are positive values we have, students. Okay. And now we have to go for what? We have to go for x0 now. When I plug in x0 here, here, and here, what answers turn to be? So 1 minus 0, 0 minus 5, and 0 minus 5. Let me check again. Yeah, it is giving us minus minus plus 25 positive. So 25 positive is where? Now we have to check it somewhere here up, okay? So approximately here 25. Now students, I have to go. What is the method to do the question? Because it is a little bit difficult to check it, what kind of graph I'm getting, okay? But you can check it. There are two ways. One way is if you have a good idea without calculator, using calculator, and one with calculator. So what is x multiply with x? We got a negative. Look at here, students. I zoom for you. 2x into x, 2x square. Multiply with negative x, I get negative 3x square. 3x cube, sorry. 3x cube. You know, students, I just tell you, if I have a positive x cube comes, the graph will turn 2 times this way. But if negative x cube comes, this graph goes this way. So it means we have a negative x cube. So what is the story we have? What to do here, students? Most probably we have a graph is cutting at 1. I said before, 1 is here. So let me make a blue cuts. 1 here, 1, 2.5, and 1, 5. So graph is coming how? The graph is coming from here, this, and turns, oh, sorry, just a minute, this way, and goes up and come back this way. Okay, this graph is done. So this is done. Now if you have a not good idea what to do, then you can make a table. Okay, make a table or random numbers you can plug in. What random numbers? Because you want to see, okay, 1 is confirmed, 5 is confirmed, 2.5 confirmed. So in the middle 1 and 0, you put plug in, you can plug in, for example, half is a little bit difficult to plug in because it's without calculator paper. So that is why it is a bit difficult, but anyway, you can check the pattern. So you can plug in the middle some value. So plug in 0.5 or half. And no need to plug in 1 because it gives you 0. And in the middle of plug in 2 also. And 2.5 is no need because it is giving you 0. Then you plug in 3, 4, I think enough. And no need to plug in 5, it gives you 0. And 6 also. Why 6? And it will tell you what is the pattern. 6 will give you the value is in negative value. So in this way, you plug in these numbers in this whole equation, okay, and you can get some value. So this is a way to get do with, if you have no idea, I hope so the point is clear. Next question, he is asking this graph is less than 0. Less than 0 means below x-axis. It's called below x-axis. below x-axis, below x-axis. Now, which graph is below x-axis? You can see there are two portions are below x-axis. One, this portion is below x-axis, and one this below x-axis. So we have to answer for both. So let's see how we can answer for both. So one part is very clear. You can see clearly, and we can answer directly. What is that answer directly? Check it, please. I show in a black color line. So this line and this line. How come? Here 1 and here 2.5. So we can say that these values are below. So we can say first answer is less than 2.5 and more than 1. I think this part is clear. And even can you see your equal sign, student? Look at here. He put equal sign. If equal sign is not there, we will not put there even there. But equal sign is there, I will put equal sign here. So it means this equal sign we are bound to put. Okay, now student, what is after that below x-axis? This is a below x-axis, and that is only possible when after 5, after 5. So it means after 5, and how to answer more than 5 and equal also. So I think the point is very clear, and the question number 1 is completely done. Question number 2, student, we have this is p of x is given and a, b's are integers. It is not a fraction. And x is a factor. Factor means when I put x plus 2 is equal to 0, when I will plug in x plus 2 is equals to 0, I will get x is equal to -2. I replace the whole equation. Then when I replace every equation by -2 must be 0. So let's start. 2x cube plus a plus ax square plus 13x plus b. I'm replacing every x by what? -2. So replacing left side -2, replacing right side also -2. And this is 0. Why is 0? Because he said factor word. And I'm getting here 8 to the 16. And is a positive 4a. And minus 26 plus b. And I'm getting what equation, students? 4a plus b. And this is becoming 30 and 42. 42, okay? So 42. And this become positive 42. Equation 1 done. First equation done, students. Now he's saying that then when you divide the same thing x plus 1. So I'm doing with the x plus 1. X plus 1. If I do x plus 1 is equals to 0. I have to plug in -1. That p of -1 is equal to what? 6. Why? He said remainder 6. So I'm doing story number next. So replace this equation. I'm replacing everywhere every x by -1. So when I put -1 here, -1 here, -1 here, and -1. Here I'm putting z6, okay. And -2 and positive a, -13 plus b. So I'm getting finally a plus b. This is becoming -15. -15 goes there and become 21. So two equations are done. Two equations are done. Now we have to do solve them simultaneously. Okay. All right. So now how to do it? 4a plus b equal to 42 and a plus b is equal to 21. I must change sign changes. This cancel 3a. And here I got a 21. I got a 21. And a becomes 7. Done. This a I can plug in any equation. I plug in it here. So 7 plus b equal to 21 and b is equal to 21 minus 7 and b becomes 14. So I hope so this part is clear. And for next part is to show this equation, this equal has one root. So how to do this one? So first p of x. P of x where, students? P of x is upper equation. So p of x upper equation. So step number 1. I'm copying this complete equation by plugging the x and y values. Okay, I'm putting 2x to power 3 and this 7 value will go back. So I can say here plus 7x to power 2 plus 13x and plus 14 is equals to 0. Now, student, how to get the other factors? Listen to me. With the word factor, use factor. I will not talk about x plus 1. I will talk about x plus 2 because factor word. I will keep x plus 2 outside and do a long division. Have a check, please. X plus 2, I'm keeping outside. And complete equation, this one will come inside. Like this. Now, x multiply what? Give you this answer, 2x to power 2. So I'm getting 2x cube and I'm getting 4x square. Sign must change. Like this cancel out. And I'm getting here 3x to power 2 plus 13x and plus 14. So this multiply what give you this value? So naturally is plus 3x. This cancel out. And I'm getting here 7x plus 14. Now this multiply what give you this number? Plus 7. And I got this remainder. Now, very important part about to come. And what is that important part? Listen carefully, please, everyone. What is the important part? If you have 12 inside and 2 outside, 2 6 are 12. So we can say the inside number is basically equal to product of quotient and divisor. This is a very important thing. So this dividend equals to quotient into divisor. So same story here. Same story here. I can say this is basically equal to quotient into divisor. So this whole thing I replace. You can see, students. So this complete thing I have it here. So I'm replacing by what? This is the same thing is in dividend. So this into this. So x plus 2 into quotient. Is question complete done? No. He said show that it has only one real root. And real root is coming from here. It means it has no real root. How to justify? You will consider this part only. Consider 2x to power 2 plus 3x and plus 7. And prove it this. Look at now b square minus 4ac. B is 3, 4, A is 2, 7 is C is C. C is 7, 9 minus 8, 56. And we are getting here 47, which is negative 47, students. So it is a very clear when you have this kind of situation comes, it means no real root will come from here. No real root will come from here. So hence, or you can say so x plus 2 is equal to 0 and x is equal to negative 2. So it is only one real root. Is only one real root. Because he said that, prove it one real root. So it is not, this is not giving you any root. So root will come from here only. I think idea is clear. And the question is completely over. Question number 3, students, we have now the sum of the first two terms of geometrical progression is 9 and sum of the infinity of geometrical progression is 25. So we have to first term, geometrical progression first term is A, second term is multiply always by R, we get AR, and third term is AR, again multiply by AR square, but no need. We said sum of the first two terms. So it means A plus AR is equals to 9. Because he said that sum of the first two terms and sum of infinity is a 25. So I'm writing here sum of infinity is equals to 25. So first of all, what is infinity formula? A over 1 minus r equals to 25. So what I can do here, students, I can take a common from here. 1 plus r is equals to 9. And a value is becoming with us. We are getting here 9 over 1 plus r. This value, I'm going to plug in it here. But problem is only here. So when I plug in this complete value in the numerator, so this will slip and multiply with this number. So I can say here, Okay, I'm just bringing this part here so we can do it easily from here. So I'm replacing the value a over 1 minus r is already exist, and 1 plus r comes from there even. How come when this value will come here? So these are 9, not a. This is 9. 9 come from here, and 9 here, and 9 here, and this 9 here. Now this is a denominator, if first term same, second term same, sign opposite, we can say square of first term minus square of second term. So 1 minus r square. So I'm doing cross multiply, students. When I do cross multiply, so 9 is equals to 25 times to 1 minus r square. 25 will come down is equals to 1 minus r square. R squared left side, and this will go on the other side. So r to power 2 is equals to 16 over 25. And take a root of the both side plus and minus 4 over 5. And he said values of common ratios. So we got a two values, students, for a positive and negative. And he said that find the possible values of common ratio of this geometrical progression. And that's it. And we have done it. And find the first term of the geometrical progression if each possible values are common ratio. It means I will use both 4 over 5 and negative 4 over 5. And I will use which formula? I'll use this formula. A over is equals to 9 over 1 plus 4 over 5. A is equals to 9 over 1 minus 4 over 5. And I take LCM from here, students. LCM is 9 ones are 9, 5 plus 4 over 9, and this 5 will multiply up. And I get it here, 9 already into 5, and over 9 cancel out. So we are getting a value 5. And here I can do directly, but I'm just doing step by step. You can understand clearly. LCM 5 and 5 minus 4. It will go up. 9 into 5 and 1. So ultimately we get a 45. So I hope so. The concept of the question is completely clear. Question number 4, students, we have now show that this equation can be written in this form and to be found, constant to be found. So step number 1, you can see 2 outside, so we have to take common. But 2 is not available with 5, so 2 will go in denominator. So after this, what to do? Both copy, and now a space of the two terms, and take half of this number. And half of 5 over 2 is 5 over 4, and take square of this number. So one time add and one time subtract. So these three terms will combine. And this left behind inside a bracket, negative 25 over 16. Now these two multiply here and multiply with this number. So I'm getting 2 times 2x plus 5 over this one, 25 over 8. And 3 is a 24. Negative 25 plus 24 is giving negative 1. So finally we get x plus 5 by whole square and negative 1 over 8. So I hope so this part is clear. And we have done first part, but he was asking us what is A and what is B. A is 5 upon 4 and B is negative. Don't say 1 by 8. So we are bound to say, we are bound to write here, A is 5 upon 4 and B is negative 1 over 8. Write down the coordinates of stationary point. Whenever we look coordinate stationary point, what we do always, we put under power 2 equal to 0. So when I put equal to 0, students, it goes on the other side, and x value is a negative 5 upon 4. This x value. How to get y values? So either you plug in this value in equation of curve, or the outside number is a y coordinate. So y coordinate is directly -1 over 8. So because it's a positive here, student, we have two ideas. If negative comes, so point of maxima. If we have a positive comes, then point of minima. And stationary point of these coordinates are very simple. X is this, y is this. So -5/4 and -1 over 8. So I hope so. This is very clear how I got point of minima. Okay. Next part, fx is this is given, fx more than p, and f inverse exists. Students, for your information, when we do a horizontal line test of any parabolic curve, it is cutting the 2 points. To avoid these 2 points, what we'll do, students, we will make a cut. We will make the graph half cut. Okay, so it means from turning point, I will erase one part. And now he's saying, you can see a cut here, because he's saying that x is more than p. So this turning point and onwards. And what is this x value? So this x value is -5/4. So it means x value more than 5/4. If I sketch it, so I have a one part of curve, not both part of curve. And when you have a one part of curve, the inverse exists then. The least value of the p is this one number, and remaining higher values also is helpful, but the least number is this one. So p value is becoming with us -5/4, and that's it. And the question is completely clear. And I think question is completely done. And what he said further, 1 mark only. Okay, let's go next question. Next part, we question, use your graph of p, this value p, sketch the graph f and f inverse, and label this each graph, and state the intercepts of the each graph on x-axis, on the axis, sorry. Not x, it can be both or only one. Okay. For that reason, what I'm going to do, I'm going to do one part very, very clear. I need two things. Okay, I need curve equation I need, which I can take from here, and stationary point is need. So I need basically two parts. So I'm going to make it now here. This value is not important to take it. So we are looking for these two things. And why this diagram is important to help to sketch. Okay, now one more thing is what? He is asking for, if this function is given, I can plug in, this is a y, is basically, so one time I'm going to plug in x0. When I plug in x0, students, okay, I can use the other equation also, because maybe that is easier to find it. How? If I plug in x0 here, I get 3. So there's easier from here. So it means 3. So y value is coming 3. So it means this 0, 3 is very clear. And the other point, how to get that one, I will plug in x0. Okay, I will plug in y0. If I plug in y0, students, what is happening then? If I plug in y0, students, y0, or I do it here even. So 0 is equal to 2 times 2x plus 5/4. 1/8 goes this side. Okay, 2 will go down. 2 will go down. I get 16. And I will take a root now. When I take a root, students, I get a plus and minus 1/4. Okay, 1/4, I take it. So if I take it plus or minus, two options we have. So 1/4 minus 5/4, I'm getting here -1. -1/4 and -5/4. And wait a minute, I think or root, okay, correct, okay. So I'm getting here -6, -6, -6/4. I'm getting -1.5. But wait a minute, let me check again. If I plug in x0, if I plug in y0, so y0 2 at 16, root is a 4. So this is a 5 upon 4. Let me recheck once again. Okay. Now this is done. Correct. Okay. And I get here -4, -1. Correct, students. Okay. Now we got it this one right. So it means this is not possible. This is a -2/3. I got it. Now, students, I will use which 2 point? Let's see now. Okay, because I'm going for the right part. Okay, that is why. So I will go right part of graph. So first of all, this one. So it means basically I got a x0, y5, x0, y3. x0, y3 is this number here. And second number, I will take it two possibilities we have. So that is turning points we have basically. If we check it, this -1, students, the graph is coming with us is this. How come this one, student, you may ask? Because the graph is starting from -1.5. This is a -1.25. So because if I check it, 5/4, it is giving 1.25. So -1.25. And this value is smaller than that. That is why we did not take that number. So it means this is a turning point somewhere here and graph turns like that. Okay. So this is second point. I will not take that one. So this is done, student. I will stop at turning point. Turning point is somewhere here. And that turning point is coming with us. What number? -1.25. There's a -1.25. Okay, now student, this same graph, basically I have this part of graph, from here to here, I have this graph. I think point is very clear. Okay, now I will draw, student, what? I will make a line here, y is equals to line. This is done. Okay, now I'm going to make it reflection. So what is the technique, student? Reflection, we can make it. How much this? Same here. So this point is there and this point is here. This point is, I think this line is slightly wrong. Not wrong. I have to take equal space. This line is okay. And let me erase the previous one. Okay. And I drag slightly down. Okay. Now students, see how much this one distance, almost same distance here. -1. Okay. Now, and this is how much this gap and same gap here, 3. I think point is very clear. And now I'm going to draw a reflection of it. That's it. And I hope so you're understanding, students. This graph and that graph are a reflection of each other in line y equal to x. So what he was asking, state we have to show these 2 points are compulsory. These are very important. Okay, I hope so. The concept of the question is fully clear. Question number 5, students, we have write this in a single logarithm of base 10. So base 10, and for your information, LG of x is basically LOG of base 10. Okay, so now we have to write it. So I can replace, first of all, every LG, remove it. It's not compulsory, but it's good to do. Or you can write at the end even, no problem at all. So I'm writing every logarithm with a base 10, but 3 alone. Can I say 3 into 1? Yes, 1. Can I remove 1 and replace here log logarithm 10 base 10? Perfect, because this is equal to 1. And 3 will go in the power of it. I can say 5 and not even that. This power will go in the power, 4 will go in a power, because we need a single logarithm. A to power 5 minus logarithm base 10 and b to power 4 and minus logarithm 10 base and 10 to power 3. Now I can write one logarithm and for your information, there's a plus sign here. So this will go up and this negative sign. So these both values will go in denominator. So it means a to power 5 up and b to power okay, what is this one? 1000. So I can write here 1000 and b to power 4 in denominator. You write in bracket or you don't write in bracket, no problem at all. So I hope so this part is very clear. And we have done it and this is okay. And let's go for next question. And next question with that part is a B part. B part, what he is asking for B part, students, if you look at carefully, he is saying we have a 5 base, we have x plus 1 base. But we have to solve it here for x now. So how we can do it, students? Get ready. So step number 1. So this is a log base 5 available. Here, no problem. But here we have two different bases. Do you know we have a property, students? Let me tell you here. If I have a and b here, and whenever I bring in denominator, complete logarithm bring in denominator. What is the plus point? So these numbers will change the places. These numbers will change their places. B will become index and A will become base. This is a rule whenever we need in a bring in denominator. So when I bring this whole thing in denominator, students, what will happen? 5 will become index and x plus 1, sorry, 5 will become base and x plus 1 is a base will become index. I think this part is clear. After this, if you look at carefully, they are exactly same. They are exactly same. If they're exactly same, so I can assume here let logarithm base 5 x plus 1 is equal to k. I got a k minus 1 over k is equals to 0. So I bring on the other side k is equal to 1 by k multiply, got a k square is equal to 1. So when I take a root of the both sides, students, I will get a two answers. Two answers I'm getting. One value is I'm getting here, k value is 1 and one value I'm getting -1. Now I bring back it here. So logarithm of 5 base x plus 1 is equal to 1 and logarithm of 5 base of x plus 1 is equals to -1. And I'm looking for the both values, students. Basically, what is the base here? 5. I said before, if index and base same, answer is 1. If 2, 2 or 5, 5. So I can replace this one by 5. How 5? Look at now. LOG of 5 by 5. Same here. This I can write logarithm of 5 base 5. And this log cancel out. I got x plus 1 equal to 5 and x become 4. What about other? This negative sign can go in a power. So I can say logarithm log of 5 base and x plus 1 is here. I can say this is coming with us logarithm 5 base and 5 to power -1. They cancel out. Due to the negative sign, you can't cancel. Make sure. So I got x plus 1 is equal to 5 power 1 -1. It goes down. When it goes down because power negative, that is why. 1 goes on the other side, 1 by 5 -1. So I'm getting finally answer -4 upon 5. Then we will check it. Is this our answer in range or not? Check it on top. Sometime we have to plug in it here and get the answer. So +1. If I add +1 in this, 5 LCM -4 plus 5, it becomes positive. It's a positive value. It is a positive value. It means both answers are okay. And we must need a positive answer. If negative answer coming, it means then undefined is there. I hope so. The concept of question is very clear. Question number 6, students, we have two ways to start this question. Way number 1, if I square both sides, student check it, square left side and square right side. But it's a very complicated because there are 3 terms inside. Second method is what? Second method, there are 2 signs are there, plus and minus. Whenever modulus is given, so here let's say we have a 3. So one time we write x plus 2 equal to +3 and one time we write x plus 2 is equal to -3. I think very clear, plus and -3. So that is the reason same criteria we can apply now. Students get ready. So what I'm going to write now. So 2x square plus x minus 10 is equals to one time plus 5 and one time minus 5. So I will do one by one. So consider I'm doing, okay, I have a reasonable space, so I'm doing it here positive and there negative. So same equation, I'm copying and paste here and with the negative sign. Now 5 will come this side, we get 2x square plus x minus 15 equal to 0. So 2x square plus x and negative 5 is equal to 0. Now 15 twos are 30 and 6 fives are 30. 6 fives are 30. Now I can take 2x common, I get x plus 3 and negative 5 common, x plus 3. I'm getting here x plus 3 and 2x minus 5 is equals to 0. 1 time x plus 3 is equals to 0. 1 time 2x minus 5 equal to 0. I got one negative 3 and one answer is 5/2. Now students, same way I can go for other one. If I apply here, or 5 twos are 10. So 5 twos are 10. I don't think so we can apply any factorization. So we have to go for quadratic formula. And wait a minute, before I start, hold on. What I can see, I can sense here, are these okay? We can apply, no problem. Negative b plus and minus b square minus 4a into c. C is a negative 5 over 2a. So we are getting here negative 1 plus and minus over 4. Inside 5 to the 10, 40 and 41 root I'm getting. 41 root I'm getting. So you can see students, we are getting here two numbers are fraction. Okay, we're getting 4 answers here. Negative 1 plus root 41 over 4. And the last answer, negative 1, negative root 41 over 4. And I hope so the concept of the question is very, very clear. Question number 7, students, we have the point ABC given. You can see clearly ABC given. So job number 1, gradients of line AB, AC, and BC. So first of line AB gradient. So y2 minus y1 over x2 minus x1. I'm getting 6 over 8. 2 3s are 2 4s are. Now gradient of BC. I'm going to use these two coordinates. So 10 minus 2 over 6 minus 12. I got an 8 by negative 6. So negative 4 over 3. Now last one is CA or AC. So I'm using the last one, the first one. So 4 minus 2, negative 2, negative 12. So I got 2 by negative 14. I got negative 1 over 7. So let me check once again. 4 minus 2, yeah, negative 14 and 2. Correct, okay. So now you students, this is done. Find equation of circle which passes through ABC. Okay, now students, very important property we have. If you remember, we done in even general mathematics and even this addition mathematics. Property what we have, whenever we have a diameter, when we have a diameter, this is a O and this is a A and this is a C, just imagine. And if I have a B here B, join A with B and join B with C. So this angle will be 100% 90 degree. How we can know that? And you know, whenever the 90 degree, so their gradient, BC gradient and AB gradient. Repeat my words, BC is here, AB is here. And the gradients product, if you check it, 3 cancel, 4 cancel, and we get a -1. It means the product of them is -1. So we can say that clearly as gradient of AB times to gradient of BC is equals to -1. So AB is perpendicular to BC. Now it means O will be called as a center of circle. I'm going to find out the average midpoint of A and C. So now I'm finding midpoint formula x1 plus x2 divided by 2 and y1 plus y2 divided by 2. I'm considering A and C. So A on the top, C down. So -2 plus 12 over 2 and 4 plus 2 over 2. Let me recheck again. Yes, correct copies. Okay. I got a 10, I got a 5, and I got a 3. So center of circle, I mean O, is 5, 3. All right. We can call as a not O, we can call as any other letter. O just behaves like a origin, not a region. This D center and D coordinates is a 5, 3. But question comes, we have to find our equation of circle. How to find equation of circle, students? We are looking for the distance, the radius. The radius what? We can go for AD distance, not hard job, or radius distance, or AC distance divided by 2. So we have, okay, let me check. A coordinates is -2, 4. A coordinate is -2, 4. I think I can go for distance formula on A and D. And formula you know very well, y2 minus y1 whole square plus x2 minus x1 whole square. I can start from any point. Okay, I'm saying 4 minus 3 whole square and -2, -5 whole square. And I got a 1 from here and 749. So I got a 50 distance, 50 root. So equation of circle is x minus a whole square y minus b whole square equal to r square. A is 5, A and B is very clear. So A is 5 and B is 3. And radius is root 50. And you know, root 50, if I apply root cancel out, I will write directly 50. And I hope so the point is clear and we have done equation of circle. And question is completely clear. Question number 8, students, we have. And question number 8, what we have, we have to sketch a graph. You can see clearly. State the intercepts of axis, I mean x and y axis, and state asymptote equation. All of you familiar, whenever logarithm, so inside the value cannot be 0, impossible, it gives infinity, and even the negative value is also give us infinity. So in this sense, I can say that my graph in the value, whatever inside the value should be 0 and above. I repeat my word, this value should be not 0, not 0. Sorry to say, I'm doing it now below. So I'm writing that value should be 0 and above. No put equal sign. Don't put equal sign. Okay, 3 will go on the other side. 4 divide. And I'm getting here positive 304. Positive 304 is, 1 minute please, let me check. Is a positive there. It goes there, become negative. Sorry, negative. So it means negative 304. Negative 304 is where? If I mention this is a -1, let's say, this is a +1, let's say. So negative 304 is if I make a 4 equal parts. So you can see, students, clearly this negative coming here. So this point I'm writing here negative 304. And this number will behave as an asymptote. And you can see now, inshallah, you will come to know. Let me make it asymptote first. And then I explain why this asymptote we have. Okay. Now, students, get ready. Okay. Now I'm going to complete it. And one more thing we have to do it set because he said x-axis. Oh, sorry, not x and y both. One time x0 and one time y0. So when I plug in x0 on the top equation, so I'm getting what, students? So x0. So I'm getting y is equal to 5 times 2, 0 plus 3. And 1 times 0 is equal to 5 logarithm of 4x plus 3. I'm going to find, this is a, it becomes what, student? It becomes y is equals to 5 times 2 log of 3. It means this number is approximately, we have a positive number approximately here, okay? And when, when x is 0, always on y-axis. So approximately number is coming somewhere here. And even I'm labeled here, ln3. And where is this number? So if I plug in y0, y will go under it, will finish automatically log of 4x plus 3. And we can replace this 0 by ln1 because we know that logarithm of 1 is 0. Log cancel, 1 is equal to 4x plus 3. Why is 4 marks? The reason is very clear to us that why this is a 4-mark question. I got negative half, and negative half is a x value. Negative half is x. Where's negative half? Negative half is, this is a negative half. Sorry. Yeah, this is a negative half. This is a negative half. So it means graph will come from the top, will cut like this, and become parallel to the asymptote. And I believe the point is very clear. And we have to show these both points, and I'm writing now negative half here. So these 2 points are very, very clear. Let me check. Negative 2 by 4, negative half. Yes. So I hope so. The concept of the question is completely clear. Question number 9, students, we have, and question statement is what? Function curve is given, and it's the second differentiation is given. And we're looking, and the curve is this given, okay, and point is given. We define a coordinate station point. First of all, I just tell basic planning. Planning is what? When we have a function, this is called curve equation, okay? When we differentiate, we get what, students? F dash of x. This is called differentiation. If we differentiate again, I'll get f double dash of x. But if I want to go, this is differentiation, and this is called differentiation. If you want to go reverse process, this is called integration. A reverse process is integration. I believe the point is very clear. And I am on second derivative right now. Okay, you know it, when I do integration of second derivative, I will get first derivative. So this second derivative will convert into first differentiation. And how to do this one? You know it very well. Increase a power by 1. Let me first write it. Okay, now I'm writing now here, students. What is the story? Increase a power by 1. So I got a negative half, and divide by same into 2. This 2 comes from where? The base differentiation, and plus C1. This 2 to cancel out. I'm writing in another format. You write like this, even no problem at all. No problem at all. Or bring in denominator. It means f dash of x is basically negative 1 over root of 2x plus 5 and plus c1. Now, students, I'm going to plug in. You know, this is also called a gradient. Okay, f dash of x also called gradient. So 2 by 3 will go in the place of gradient. I'm going to replace here 2 by 3. Same time, every x replaced by 2. So 2 2s are 4 plus 5, 9. I'm getting here 3. So negative 1 over 3 plus C1. It goes there, and I'm getting C1 coming from here. So I'm getting here 1. So this one I'm going to plug in back in equation. So I'm getting finally, not finally, this is our final first differentiation. I'm getting this format, and plus 1 is there. Now we have to we're looking for the coordinates. Whenever looking coordinates, I must need equation of curve. Do we have equation of curve? Not at all. I am on this level. I have to integrate once again. So it means again integration. So when I integration again, I will get what here? Function of f is also called curve equation. I am bound to bring it up. I'm bound to bring it up. So this will become negative half. So I'm going to integrate it. It is very, very clear. So students, I'm going to integrate it. And now what is the rule of integration? You know it very well. Increase the power by 1. I'm getting half, and half down into 2. This 2 comes from the x coefficient. And this integration of 1 will become x and plus c2. Simplify maximum, so I'm getting f of x is equals to negative root of 2x plus 5 and plus x plus c2. Now I'm going to check on top. Point is given 2, 2. So it means x is 2, y 2. This is called y. So I'm putting 2, 2. 2 here, 2 to the 4 plus 5, 9. The 9 is root 3, so 3 we get. Even 2 here. So I'm getting here 2. This is because negative 1 goes there and I got a 3. So C2 value becomes 3. And I'm going to plug in back in equation. And final form of equation is with us is this. But is it the answer? Not at all. He is asking finally from here, from us, find out, just a minute, please. This is, let me check once again. Yes, this is correct, okay. And one finally, yeah, he is asking from us what? He said, no, find out the coordinates of a stationary point. So how to do it, students? What is the normal process? We always put derivative equal to 0. But where is derivative? Derivative we have already here given. So it means what I'm going to do, I'm going to integrate that one. So hold on, space is a problem. So I'm shifting it as a, wait a minute, let me erase this. Okay, I'm shifting this whole equation slightly left side. Okay, now I'm looking for here. Okay, I'm doing it now here. I'm looking for stationary point there. So I'm putting here derivative 0. So I'm writing here put f dash of x is equal to 0. When I plug in 0 here, students, what is the story then? So 0 is equals to negative 1 over root of 2x plus 5 plus 1. This completely goes this side, will become this format. Cross multiply and squaring both sides, I get 2x plus 5 equal to 1. So x becomes negative 4, negative 2 comes. And but is the question done? Not at all. We have to find out not even that. We have to find out a y coordinate. So this negative 2, I'm going to plug in it here in a whole equation. And I hope so, inshallah, easy, nothing hard for us to do it. Okay, this is value I have already available with us. 1 minute. Slightly left side. Okay. Now, students, I'm going to apply the plug in the values. Where plug in the values, students? This value I'm going to plug in this equation, and I'll get my answer. So I'm getting y. When I plug in negative 2 here, negative 2, negative 4, root is 1 is 1 here, minus 1. And negative 2 here, I get this. And y coordinate I'm getting is 0. So it means the coordinate is x is negative 2 and y is 0. And this is my final answer. And I hope so. The point of this concept is very clear. Yes, students, part B, we have find nature of the root, okay, nature of the roots or points, stationary points, what to do. You know it very well. What is the basic criteria? If second derivative value after putting x value is positive, is called point of minima. And if second differentiation sign is coming negative, is called point of maxima. So we have a secondary differentiation equation we have from previous page is this. Okay, now students, I'm going to plug in the coordinate. Coordinate is x is negative 2. X is negative 2. Okay, students, and I'm going to plug in this second derivative in this equation, negative 2. So let's start. So I'm putting x is equals to negative 2. When I plug in negative 2 in each x, so negative 2, I got a negative 4 and I got a 1, positive 1. And positive 1 means is a point of minima. So point of minima. So I hope so. The point is very clear. And we have done, yes, we have done this value. And we have to check it. I think we have, let me check another point or only one point. And no, I think so. Stationary point is set. So I think question is completely clear now, and all parts are clear. Question number 10, students, we have here. First of all, you can see on top squaring identity we can apply. So when I apply squaring identity, so first term square, positive 2 into first term, into second term, and plus second term square. So this I expanded for the first part. Same thing I'm copying. So I'm pasting the second part here. But this time only I will plug in negative here. Reason because negative in the middle. So negative, and here in the middle plus because there's a plus. And I hope so this part is clear, and we limits are very clear, negative pi by 2 and 3 pi by 2. And d theta at the end. You can see this negative do's and this positive. They will cancel out. And sine square plus sine square 2 sine square and this 2 cos square. So I'm getting here 2 sine square theta plus 2 cos square theta and 2 common from there. When 2 common, students, what happens? Inside we have 2 common. Inside we have sine square theta plus cos square theta, which is 1. So 1, 2s are 2. So I'm not wasting your time writing directly here. It means this is equals to what? 2. And what is integration of 2 is 2 theta. The limits are very clear, pi by 2, 3 pi by 2. And I'm going to plug in 1 by 1. When I plug in 3 pi by 2, upper limit done, minus pi by 2, lower limit done. This cancel out. So I'm getting here 2 pi unit square because it will always give us area. So I hope so this part is clear. Question number 11. And we have to apply. First of all, I just give a plan. NCR formula is n factorial over r factorial into the difference of n and r factorial. So same criteria I'm going to apply here. So I'm writing here n minus 4 is there already times 2. What to write up and down you can see from here. And I'm writing here n plus 1 factorial and 5 factorial and the difference of both values factorial. And what about this same story, n plus 2 factorial over 7 factorial, n plus 2 minus 7 whole factorial. Now we see gradually 1 by 1. So this is bigger or this is bigger. You know, n plus 2 is bigger. Which is bigger value, I will expand. N plus 2 and 1 less means is n plus 1. Factorial, same time which we write it. Because let's say 6 factorial, I have to open 6 into 5. I want to put a break, stop here. So I will write factorial same time, the same story we have. So in this side, left-hand side, we have n plus 1 whole factorial. This is cancelled naturally, very clear. And this is, I'm getting n minus 4 in the numerator. So 7 is bigger, 5 is smaller. Smaller, I never open. What about this? I'm getting here what? I'm getting n minus 4 whole factorial. And this is, I'm getting here 7 factorial. We have already 7, open it, 7 into 6. I want to stop here 5 factorial because this match. Okay. And then student, what to do? What is this one? This is becoming with us is n minus 5 factorial. N minus 5 is bigger, n minus 4 is bigger. If I subtract 1, I will get a match. So it means this is a bigger, I'm going to expand it. So 5 factorial into n minus 4 and 1 more less n minus 5 and stop same time with factorial sign. Okay, and here I got a 42 into 5 factorial and n minus 5 as it is. Now this is cancel with this cancel with this cancel with this. Now what left behind, students? We can say that 1 is equals to n plus 2 over 42. 42 is equal to n plus 2. You can see clearly and we can find out our answer easily. And if we look at here, so n is becoming with us is to subtract 40. I hope so. The point is very clear and question is completely done. 10 and 11. Question number 12, students, we have. So we have to go for differentiation, sorry, because very clearly mentioned when x is 0. But thing is, their quotient formula, what is the quotient? So when two functions divide, so we always take square of denominator, which is squared, copy as it is into u dash. Now you copy v dash. Okay, I'm going to apply same quotient formula here, x minus 2 whole square, which I'm squaring, leave as it is into exponential differentiation. First, we copy into powers differentiation. I think this part is clear. Minus. Now, e to power x square copy and differentiation of denominator. So 1 minus 0. I have to plug in x0 and I think so directly plug in x0 to save our time. Let me check below what we have. Okay, we need rate of change of x. So we need it, okay, x0. So I'm putting x0 here. So when I plug in x0, students, what will happen? 0 plug in it here. I'm getting here -2. When 0 plug in here, sorry to say, it is a full 0. So full 0, no need to waste time. Because this 0 full 0. When I plug in 0 here, something to power 0 is 1. And when I plug in 0 here, so -2 square give us 4. So I'm getting here dy over dx is equals to -1 over 4. Now we have to go for the next part is saying if when x is 0, y is increasing at a rate of 0.5 unit per second. Okay, I'm doing the same area. Basically, dy over dt is 0.5 is given from here. We can take it. Okay. And he's asking rate of change of x. So our job is dx over dt to find. I will apply here chain rule. So have a look here, chain rule. And how to start chain rule, students? What is unknown? Start from there. So dx over dt. And we write two fractions. This goes in the first numerator. This goes in second denominator. And dy and dy. This value we have already, and this value we just got it, but in a reciprocal form. So it means this will become -4 into 0.5. If I check it, there's a half, basically 0.5. And we are getting -2. And units per second. Let me check. Yeah, correct. Okay, student, after this, we have this is done, students. On next page, we have one last question of the paper. And what question we have? He said, find y in terms of x when we have given this condition. X value is between -1 and +1. And we have these two conditions. So how we can do it, students? So first of all, we have a cot and sine given there. And what is a cot, if you remember? So we have to, you see, y in terms of x. So theta not be there. So we have to eliminate theta. But how we can do it? So sine is given. So I think first of all, I make a sine subject. So sine theta, how to make it? This will go left side, x will go right side. So 3 sine theta is equals to 2 minus x. And if I bring 3 down, so sine theta is equals to 2 minus x over 3. I'm looking for cos value. What is the cos value? Basically, we have cos squared theta plus sine squared theta is equals to 1. If I take a cos theta subject, so it will go on the other side, 1 minus sine squared theta, take a root of this. This value is going to come here, and in this way we can find easily 1 minus 2 minus x over 3 and whole square root. Okay, students, what to do onwards? So this is a cos value, I got it. I'm looking for cot square. What is a cot square? So y is equals to 3 cot square. Cot square we have already given. Cot means cos over sine. So this value without root is coming up and this value is going down. I hope so the point is very clear. So this, so as I said before, so I'm going to replace a value, but this is a without root. So I'm getting here, students, so 3 times 2 in the bracket 1 minus 2 minus x over 3 whole square. And sine square value is this. So I'm writing now 2 minus x over 3 whole square. And I hope so the point is very clear, students. And we are looking for the y value. So student, we have a rule of algebra, a plus b over c. We can write a over c plus b over c. This is a splitting criteria we're going to apply here. So this is a minus b or plus b, no problem at all. This is behaving like a and this is a b and this is a c. So I can do a splitting criteria same, 3 outside, 1 over 2 minus x over 3 whole square. So this over this is done. Now this over this I'm going to do. So 2 minus x over 3 whole square divided by 2 minus x minus 3 whole square. And this is a completely cancel out and we are getting 1. And student, this is a rule of algebra, 1 over a by b. Or you can check in calculator, students. If I have a 5 over 6, this will flip up and give you 6 over 5. So this you can type in calculator, you get this answer. In the same sense, this will go up. So 3 outside, and in the bracket, this 3 goes up. So 3 over 2 minus x whole squared negative 1, because they cancel, give us 1. Now, is this done? Yes, we can say this done as well. Or maximum, you can open the bracket. You can say 9 over 2 minus x whole squared minus 1. And this is our final answer. I hope so. Concept is clear and paper is completely over. So best of luck for upcoming exam. May Allah help you. So pray for me. Assalamu alaikum wa rahmatullahi wa barakatuh.